Step on and start your share.
Hey, good afternoon or um, evening, depending where you are in the world. Can everyone hear me okay? Is that coming through okay?
Loud and clear.
Yep, great. Okay, well, I'm Ian Chilton from LonApp. We're an internet exchange point in the UK. I recently did an episode of the NetBox Heroes podcast. So if you kind of want more information about me or LonApp or I use a NetBox or anything like that, then do check that out. I also recently gave a presentation at Net DevOps Days London, the event Mark mentioned earlier. This is kind of a very cut down snippet of that. So again, if you're kind of interested in things I talk about here, I believe the videos of that conference will be released shortly. So do check those out. Very quick introduction to LonApp. We're a not-for-profit neutral internet exchange point. We have about 8 points of presence across 7 of the major London data centers. We have approximately 250 members, 350 connected ports. We peak at a terabit per second of traffic. And we do all that with 4 full-time staff. These are our points of presence. So we run a leaf spine topology, light and dark fiber between all of these sites. So diving straight into network automation, a couple of years ago, I set up this kind of structure. So we had SaltStack, which handled our automation that used Napalm to talk to switches. Then we took data from a variety of sources. We took templates that were in Ginger, config from GitLab repos, obviously NetBox. We use NetBox a lot for our inventory management, for our VLAN and IP address management. We have plans to use it for a lot more in the future. And then we take a lot of data from IXP Manager, which is all of our members and ports they have with us. That's kind of like our CRM and also our portal for members to get graphs and information and all that kind of thing. This worked well for a couple of years, but I wasn't really using much of SaltStack, if you like. A lot of the logic was built into the templates. We were basically just using SaltStack to parse those templates and inject some data. So more recently, what I started doing is replacing SaltStack with our own code, which kind of talk about here. So that brings it all within our control instead of relying on a big open source project like SaltStack. It then has minimal dependencies. It can be faster because it hasn't got that overhead of a big project like SaltStack. It can be more flexible, and we can design the interface and the scope of the tooling exactly how we want it to. So I just kind of wanted to give it's not a live demo, but just a kind of glimpse of how that works. So basically we can call it with some parameters. We want to target certain switches, and then we've got like an action and parameter kind of system. So then we can use that to target different devices. So there's a action called targets, which will show me what devices would be targeted if I ran it. So we can target single device, multiple devices. We can put wildcards in there. We can say, oh, we only want to do edge boxes and ignore the spines. We can exclude boxes. We can even exclude with wildcards as well. Then what we can also do is target all boxes. And if we target more than one host, it then uses threads to run all this concurrently. So we're not waiting for each box to come back. It does it all concurrently. And then I'll just give an example of some of the things, we can, not very interesting, but we can pull facts from the various devices. So for instance, across a load of devices, what versions are they running, what models are the switches, etc. We can, this isn't something we'd normally do, because normally we would parse templates to apply configuration, but we could this is just a kind of example of the flow, if you like. We can manually set a certain config on a box. that then, like I say, goes off concurrently. And I've targeted 4 boxes there. That's gone off concurrently to those boxes, and it's come back and said 2 already have that config, so there are no changes. One of them actually errored, so it handles that and displays the error, and then the other one didn't have that code, so I've got a very uninteresting diff there. It's only 1 line, but it's basically saying I'm going to add that. Then it prompts us and says, do we want to commit those changes? So we can say yes, and then it goes off to just the boxes with changes and makes that change. So that's the kind of the workflow in terms of configuration changes. Like I say, normally we would parse templates and not kind of supply that config on the command line. The other thing I did with this is we use Oxidized for backups. That then pushes to both GitLab, so those backups are backed up, and in real time to our Slack channels. So if anyone else makes changes on the network, we can see that. So what this tool does is it kind of prods Oxidized and says, at the minute we make a config change using this tool, it pokes Oxidized and says, okay, go and recheck the config. That then in turn puts that diff in Slack. So as soon as I run something, my colleagues can then see that I've changed something on the network. This is an example of actually applying config from templates. So this is just a very small config snippet. You'll see it's just Arista EOS config, configuring SFlow, but then we've kind of got these data sources in here as well. So this is just referring to config that I've actually got in a Git repo elsewhere. So the templates are generic, and obviously we could push to different, in this case, we could push to different SFlow hosts, for different targets if we wanted to. And then that's just how that template renders for that device. So for that specific device, we render that template, and that's the config that comes out. Obviously that then can then be applied to the switch. This is again just the way I've kind of created templates is to have them all modular. So we've got stuff that's always common to switches, and then we've got stuff that's stuff that's specific to IXP switches as opposed to management switches or anything else. So I've kind of broken all the templates up so they're really modular, really small, and that therefore makes them really understandable. One thing we can then start doing with these tools is helping us operationally. So one thing we do, obviously we're an internet exchange point. We run a 24/7, 365-day network. If we need to do maintenance that affects member ports, we have to advertise that maintenance in advance. And then what we do is we use something called BGP session culling, where we can in a friendly way cull the traffic from member ports during maintenance. So now our automation applies that culling. So we can kind of say this device we want to put into maintenance mode. That then through the use of the template snippet I gave you there, then applies that session culling to member ports on that box. Whereas previously we used to go and apply that manually. That's just a bit of a demo of we can render that template, and that's what comes out. And then again, if we run this command, run this tooling for a box in maintenance mode, that's the kind of thing we get. So we get a diff, and then as per that earlier slide, it'll say, do you want to commit that? We can say yes, and it will go off and commit it. The way I developed this tool is to make it really easy to develop and debug these templates. So that was kind of one of the issues with SaltStack was sometimes you get like a funny error, and it can be then very difficult to debug exactly what's going on. This tool lets me pull config from boxes without actually needing to go and log on to those boxes, but it also lets me spit out what data I'm putting into those templates. It lets me spit out the rendered templates. So if anything goes wrong, I can go back and say, okay, this is the template I'm using. This is how it renders. This is the data I'm rendering it with. And, the answer then is generally obvious rather than thinking, what's this error and why on earth is this not working? And then the kind of this this part isn't done yet, but the idea behind this tool as well is not just configuration management, but as an operational tool. So things like we want to, depref links that might have a problem on them or have gone down. And then we might want to do some day-to-day activities like look up member ports and show us details of them, light levels, status, etc. What's the traffic on certain ports or certain switches? Delve into inventory of optics. So, we need a spare for a particular optic. Where is that on the network? So we can, the idea is to kind of build that kind of thing into this tooling as well. Obviously that then links into NetBox because we have all of our inventory in NetBox, both in terms of devices and hundreds and hundreds of transceivers that we've got across our network. We run scripts that probe the devices. So if we go into the data center, start swapping optics around, taking them to different sites, plugging them in, we then have a script that we can run and update NetBox with exactly where each of those optics, with whatever serial number have appeared on the network. And then just some kind of thoughts or design decisions when I was developing this tool. So obviously, if we're trying to use this tool during maintenance where it's time sensitive, or we're stood in the data center, which is not the easiest environment to stand and start making configuration changes in. It's a nightmare if the tool breaks, but this is a production critical network that's doing a lot of, like I say, up to a terabit per second of internet traffic. So we must not break the network. That's the kind of primary concern. We must generate the correct configuration and apply it to the device. It's better to fail than to generate the wrong configuration, because say one of the data sources is not available and which breaks the network. Another thing I've tried to do is reduce the dependencies. So if the network breaks, then obviously we don't want the tool to break because it can't reach dependencies, it can't pull data. Think about kind of race conditions when that screenshot I showed you earlier where it gives us a diff of the changes and says, do you want to commit them? We just need to think about the race conditions there. What happens if that data changes between me kind of saying, yes, that diff looks okay, and committing it? We want to be sure we're committing the changes that we've seen and approved, not anything that might be more current than that, any changes that might have been made in the meantime. And again, the other approach I've taken is just to cache that external data from things like NetBox and IXP Manager and all of those kind of things. So the tool will work independently of those APIs being functional and being able to reach those systems. Beware of vendor bugs. So just because you have a correct configuration, experience tells me that there might be then a bug applying that. You might have a perfectly correct configuration, which if you type it into a switch will work, but if that's applied in a certain order, or at once in a config session, then you can hit bugs in vendor software that then say crash your box or whatever. So just be aware of that kind of thing. And that's all I've got to say.
Awesome. Thanks, Ian. I know that was a condensed version of the
That
longer
was a
presentation you gave.
whirlwind tour, yeah.
So a good job on that.